Okay, this is a little counter circuit that's created just using some flip-flops and some AND gates here. Now, normally we'd be feeding a clock here to each of these, and you see that this 5-volt signal I've got here runs to each of the clocks of the J Ks. Now, the J and Ks are already enabled on this guy with 5 volts, so they're high already. They're just waiting on a clock pulse. And then the J and Ks for each of these others will get their signals from various places, and we'll kind of explore that as we go along. So remember, if the J and the K are high, and if you look, the J and K on all four of these, I should say, are tied together. So whatever J is, K will be also. Well, they will flip flop. That's the name between Q being high and not Q being high, Q being high and not Q being high, based on a clock pulse. So in other words, right now, J and K of this flip flop are high, and they will stay high obviously because they're tied directly to 5 volts. So as soon as this guy comes high, Q will be enabled. At another clock pulse, Q will not be enabled and not Q will be enabled. So this guy is just going to toggle Q, not Q, Q, not Q, Q, not Q. Get the idea. So we're going to follow this thing through its full account, and this is the bit that is tied to the first one, the second, the third, and the fourth, respectively. And you can follow those lines and see that out of each one. So as soon as I close this switch, it'd be like a clock pulse happening once. So there we go. And notice that because J and K were already high and this clock pulse went high, this Q went high. Now the next clock pulse, that Q will go low. But notice that Q is tied to the J and K here, so they're high. So this Q is going to go high just as soon as there's a clock pulse, as will this one go low. So if you look, we're counting in binary. This is our least significant digit. This is our most. So right now we went from a binary 0 to a binary 1, and we can count all the way to 15 because this is the 1, 2, 4, and 8's place. If we add those up, 1 plus 2 is 3, plus 4 is 7, plus 8 is 15. So let's see what happens. Now, we already talked about it a little bit. We said next clock pulse, not Q, is going to be enabled. This one is waiting on a clock pulse to enable this Q. And let's see if that happens. So sure enough, we go from a Q being enabled here to the not Q being, because this was high at the time, it made this high. And you got to remember, this is a chicken and egg thing. One event happens and then another event happens. Now, it may be nanoseconds in between, but that's what's happening. So we went from a 1 to a 2 because this is a 2's place. Now, in order to get binary 3, we need both of these lit. Well, this guy is not going to set to a not Q without this being high and it receiving another clock pulse. So right now it's not high, so nothing can happen to this one, but something can here. It's simply waiting on a clock pulse because it's always high. So here's our clock, and now we're 1, 1. So remember we did 1, then 2, and now both of them on being 3. So the next thing we need to have happen is this one come on. That's the one that's tied to what will be 4. These two will need to go off. And let's see if that is indeed what will happen. We know this one's going to go off as soon as we get a clock pulse because it's on. This one is already set and it's high as well, so it's going to go off. And this AND gate that's receiving these two Qs is already high, so this guy's waiting on a clock pulse just to come on. So let's see that happen. Boom, there it is, and sure enough. Now, neither of these are high. Neither the J and K of this isn't high. So the only one that can toggle now is this first one. So the next clock pulse, and that is obviously the 4 bit. Now here is number 5, so this one's on. Now this one's high, so it's going to go low. This one is waiting on a high for the Q, and it's going to go high. So we're going to see this bit go to 0, this bit go to 1. And now he is not high, so we know nothing's going to happen to this state. He is not high, nothing's going to happen here, but we are going to see it here. Boom. Now we've set up for this one to come on. Now let's look across. This queue is enabled, this queue is enabled, this queue is enabled. This JK, and this JK are high. So a clock pulse is going to turn all three of these off, giving us an 8, or excuse me, yeah, 8. And then we're just going to repeat this through the bits. We're going to go to 9, and here we go. We're high and we're high, but we're not on here. We're going to go off here and on here. We're high. We're going to change here, but not here. That gives us 10. Excuse me, 11. So there's 8, 2, and 1. So we're high and we're high. Our cues are set. So both of these are going to go off, and this guy's high, so he's going to come on. That gives us a 12. And we know this guy is waiting on a clock pulse. That gives us a 13. This is still high. This is going to go to not Q. This is going to go to Q. That gives us a 14. And then last but not least, nothing else is setting to change. That gives us a 15. And now everything is set. And on the next clock pulse, everything would go back to 0. So you get the idea of how these adders work. So just by using some JKs and configuring these properly, we can create a counter that can count from 0 to 15. So basically 16 places. So pretty cool. And we could add on to this and keep it going and make a much more complex circuit if we wanted to. So just a neat illustration of how using flip-flops and things we can create a counter.